All right, so write the balanced chemical equation for the reaction. So it says potassium chlorate. So potassium is K. Chlorate, like 8 oxygen, is on the back of the periodic table. Okay, so when you crisscross, the ones cancel out. And again, if you were a bracket kind of person, that's fine here too. Decomposes means you have one reactant breaks apart, right? Oxygen gas, oxygen is diatomic. And then potassium chloride. So this time it's just IDE, so chloride, not 8. And of course, now we know it has to be balanced. So this one is decomposition in general or synthesis. Weird things can happen. So this is a little bit weird. What don't I like? I don't like this. 3 and 2, that's odd and even. So the simplest thing you can do, put a 2 there. So now we have 2 Ks and 2 Cls. So we need a 2 there. And then this is 2 times 3. So since we already have a 2, we're going to times 3. Similar, you want to make sure the coefficients are most reduced. You can't divide 3 by an even number, so we're good. Okay? So now, how many grams of potassium chlorate must be decomposed to give 0.96 grams of oxygen? So in the previous example we did with the number of moles, we went both ways. This question's just asking us to change between oxygen and potassium chlorate. So sometimes students are like, how do I know that I have to do stoichiometry? Because it doesn't say that, right? So this is oxygen. So what I would do is write down what you're given. Grams is mass. And then the question says how many grams of potassium chlorate. That's this substance here. So are oxygen and potassium chlorate, are they the same thing? No, so you have to do Stoic. When you're trying to convert between substances, you have to do Stoic. And we never compare grams, you change it into moles. So you can write down information that you have in a similar way to like an empirical formula chart or whatever, and except this time we don't have elements, we have compounds. So we wrote M for mass. We wrote this under oxygen because that's what we were given. So to change it to moles, we need molecular weight. So oxygen is 32. Again, you can just write the answer if you want. Let me sneak in a dotted line here. You don't need to make a chart, but if you like that, it is going to look similar. And then what are we going to do next? Moles. What is moles again? Mass divided by molar mass. Okay, so exactly like the chart. This line divided by the next line. So again, decide for yourself, show the work off to the side, show the work right here, whatever you want to do, write the answer. Now hopefully you see that how many times we're going to do this calculation, that really it is kind of like, it's almost understood, like of course I'm going to have to find moles, you know? I'm going to put 2 equal signs on a line. Don't tell Mr. Todd. So you could really just write that and that would be it, okay? Sorry, so this is B. So in our triangle, in order to find mass, we need molecular weight. So you can write that in. Well, I didn't show my work here, but I can. Or you can just write the answer. Yes. Yes. So you're just looking at the substance, not the coefficient. Because we're going to use the coefficient in the ratio. Okay, easy to find. You can even put a dotted line here. Oops. If you like. But in order to get to mass, we need the moles. We don't have that. How can we get this mole into this mole? Well, that's Stoic, right? So change this into this. I could have given you any of those substances and asked you to convert them. I could have asked you for KCl. So just read the question carefully. Given oxygen, that's why it's helpful kind of to write what you're given underneath the substance. You know where it goes, and then what are you looking for, okay? It's really arbitrary. It's not, one's not better than the other. Eventually when we do percent yield, you'll want to focus on the product because you're trying to find the yield, but in a random stoichiometry question, it doesn't matter. I don't want to squish down here, so I'm going to write it over here, but you guys can do what you want, okay? So now, again, do the same thing. What am I looking for? What's my X? I need this moles. So once I choose that, this is KClO3. In the bottom has to be its coefficient. What other mole amount do I have? Only one I have is oxygen. Sorry, I have to squish. That's a terrible fraction. Mole, what goes in the bottom? Coefficient. So the Stoic ratio is the same sort of thing every single time. Put the X in the top, whatever that substance is, put its coefficient in the bottom, whatever you're given, and its coefficient. Never, never, never compare grams, okay? You have to change it into moles first. Again, like I said, if you're, okay, what's the minimum thing I should do? Anytime you see grams, change it into moles, okay? Bob's your uncle. And then you'll at least get part marks. So again, now you decide how you want to do this. Do you want to cross multiply? You can do 0.03 divided by 3 times 2. Either way, you get the same thing. I don't really have room here to do the other way. I hope that's okay. You can sort of check the logic of your answer. The coefficient or the general mole amount for oxygen would be 3. KClO3 is 2, so 3 is less than 2. That means that whatever oxygen's mole amount is, the one we found should be less, which it is. And then just read the question carefully. Does it want the amount in moles or does it want the amount in grams? So this one happens to say grams. And that would be the kind of question, if you weren't sure, you could say, Ms. Todd, am I supposed to change this back into grams? And I would say yes or no, okay? So whether you are a triangle user or a formula user or whatever you want. So when we have moles, we already found the grams per mole. So you multiply, the moles cancel out, or you use the triangle. Mass is moles times molecular weight, whatever you like best, okay? And I'm going to do it again. Don't tell Mr. Todd. .45. So the grams is useful in a practical way because we have scales to measure grams. But you can see that based on the mole amount, which is all based on Avogadro's number, then it's easier to predict what the answer should be. This mole amount should be less than this because its coefficient is less. But because its molecular weight is so much higher, then you get a way bigger gram amount. So it's taking up more space. So the amount of space something takes up is not a reasonable comparison. That's not the same. So usually what happens in these kinds of questions, even when we do the next one, limiting reagent, usually, well, once you balance the equation, then the first part of the question has the most work. And then if there's like part C, part D, part E, whatever, they are usually a lot more straightforward. So C says how many moles of potassium chloride are produced. We can either use this one or this one, and all we have to do is Stoic, that's it. And then I toss this in here, how many formula units, just to take it back to that. Again, because this is usually kind of, if you're analyzing and changing it back into grams, usually that's because you're going to practically do something with it. And the number of formula units, while it's important to understand what Avogadro's number is, it's not really, you're not going to go measure the number of formula units, right? So, but we'll just review that just in case. There we go. So now you have more space. So how many moles of potassium chloride are produced? Again, I don't know why, but usually students go back to the one they're given. It doesn't really matter. But again, how many moles of potassium chloride? That's our X. KCl, so in the bottom, you have to put its coefficient, which is 2. And then we have 2 mole amounts. You can use either one. So you can use this one, or you can use this one for whatever reason. Like I said, most students will go back to this one. Actually, you know what? I'll solve this one, not cross multiply. So then at least on this page, you have both kinds. So 0.03 divided by 3 is 0.01. And then to get rid of the 2, you have to multiply. I guess if you're a cross multiplier, I can show you. You can write, there's lots of space on there. You can certainly write down both, but you don't need to. So the moles of KCl and the moles of KClO3, how are they related? Same, different, more or less. Heather? They are the same. And the reason they're the same, they have the same general coefficient. So this is 2 to 2. So if this is 0.02, so will the other one be. Okay? So again, that's just a way you can check your answer. You could have certainly written that explanation. That would be fine. Just make sure you show some sort of work so I know you're thinking. Let's say you screwed up the balancing but carried your mistake through correctly. Then I would check your math and I would just take like maybe half a mark off. I don't penalize you every single time. So even if you're not sure, you hate balancing, whatever, just go with what you have, okay? If you know how to do Stoic, like don't just stop, like keep going. Okay, so now we're going to take this mole and change it into formula units, which is entities, right? So it was Avogadro's number times the number of moles. And it's formula units because potassium chloride is an ionic compound. So again, that is very specific to your textbook. So if you are a Khan Academy watcher or whatever, they might not use that term. I'm going to be funny. Okay, so there is 6.02 times 10 to the 23 formula units in 1 mole. How many moles do we have? Again, just read the question carefully because now technically we have 3 of them. This is KCl. To be honest, let's say you got all the way here and you did the moles of oxygen instead of KCl. If you did it correctly, I probably wouldn't even take marks off because you've shown me that you know how to do this, right? It's arbitrary. I picked potassium chloride. I could have picked potassium chlorate. I could have picked oxygen. It's all the same. So the moles cancel when you multiply. Okay, so there is a space there to write a flow chart. If you are not the kind of person who likes, sort of a summary-ish thing to this, if you'd rather just think about it, then maybe you won't find the flow chart helpful. It's kind of up to you. I'm going to use 2 colors because so you like to go from reactant to product and then product to reactant, but it's the same difference. So we'll just use the same sort of really simple general reaction that we used on the first slide. So if you're given the mass of A, never ever are we going to compare mass. So we're always changing into moles. Then if we want to get to mole B, not ration, Stoic ratio to get to mole B. Then multiply by B's molar weight, molar mass to get to mass B. So then you can go the other way, given mass B, divide by its molecular weight to get to mole B. Mole B, use a Stoic ratio to get to mole A. Actually, you can even draw another arrow. Hold on. But if you don't like this, you don't have to use it, okay?